Okay, we are still carrying on from the previous video. Okay. Um question 6.3, determine the range of f of x. Okay, what is gonna be the range here? This graph starts here at turning point at the value of y because they are concerned about y. Range is only speak to y. So this graph doesn't exist here. Doesn't exist here. That means this graph starts here. That means the value that you have to determine for range is turning points. Is our turning point, the y value, and that value is included. The graph starts at that value. That means y has to be either less, because that value exists here. I mean the graph exists here, or equal to this value. Start here going down. So y, it's less or equals to the y value of the turning point. Alright. So I will show you on the solution how do they work that one out. Streammax, because you still have to use Streammax. It's just a free Streammax because you still have to work out what the value of y is in the turning point by first using whatever method that you're gonna use. Okay, rather than the equation of g in the form of, we already discussed this one. Okay, the first thing that we need is m being the gradient, and we have 2 points here. We have this point and that point, and this point is gonna be 0 and 6. Okay, so you determine your gradient, and after having the gradient here, you can take any point between a and d to determine c, then you'll be fine afterwards. Okay. 6.5, write down the average gradient between A and D. Is still the same thing as what we did on for M here. The only difference is the fact that you have a bar here above M. Let me just show you. The average gradient is still the same gradient, is given by M bar average gradient equals to f of x instead of y, f of x2 minus f of x1 divided by x1 minus x2. So you use those values to, you use your f of x2 here, f of x1 here, and y2 and y1 to get your value. I think that one is easy. I don't have to explain much. This is because A is on f of x here, and D is on f again. And since they are saying it's an average, the gradient that you can get from point A to point B, I mean from point A to point B, is not the same as the gradient that you can get from point D to point C, or the gradient that you can get from point C to A, or the gradient that you can get from point D to A. Hence they are saying it's an average gradient. But in contrast, if you determine a gradient between this point and this point here, it's going to be the same as if you determine the gradient of this point and this point, because they are on the same straight line. There's no curve. All right, that's the difference. And it's just 1 mark. It's just 1 mark. For this part, Okay, let's see how far we can go. Let's start with this one. It's fine. Let's start with this one. Write down the values of x for which f of x is greater than 0. F of x has a positive value or is greater than 0 only when the graph is above x-axis. Let me show you this. At this point, this graph is negative. At this point, this graph is negative all the way. But at this point here, on this line, the graph is equal to 0. But above this line here, the graph is positive. The graph is greater than 0 here. It's above 0, as you see. So that means when x, that is here, the value of x that is here, okay, we're gonna say, how are we gonna structure this? We're gonna say, okay, because our target now is the fact that the interval has to be this one. So the x here, let's say here is 2 and here is -3. Any value that is greater than -3 here, if you move here, -2 would make this graph to be above 0, but -5 will mesh with this part, meaning the graph will be negative. But any value that is on this side of -3 would make this graph to be above 0. Even on this side, if we move this direction of the x, the graph is negative. But if we move this side, the graph is positive because it's above 0. Meaning this graph has to be between -3 and 2 here. How do we write that? We're gonna say x is greater than -3 and less than +2. That would be our answer if here is -3 and here is +2. We'll see that in the solution, because I don't want to write that because it's gonna take some time and I'm worried about the data as well, right? But you're still allowed to ask questions where you feel like having get much clarity. Okay. On this graph, this one, 6.6, determine the equation of h if h is a reflection of f about the x-axis. Okay, that part alone beforehand, let's first consider that part alone. They are saying we're gonna get h if we reflect f of x about x-axis. If it's about x-axis, it means that you need to put negative sign to f of x. Let me show how do we do that. Okay. Here you're gonna insert a negative sign, meaning your subject of the formula has to be positive at the end of the day. You then divide by that negative. So here it's gonna become positive, and this would become positive, and this would be negative. So that's the first part of the condition before the end. What about the end part? They are saying the graph will be shifted 3 units to the right. It's 3 units to the right, right? That means wherever you see x, you simply say you add 3. Where there is x, you add 3. It's going to the right, you subtract 3 because it's going to the right. If it was going to the left, you would add 3. Okay. How do we do that? Let me show you on the solution how would they work that out. because I'm also worried about your data. Let me show you on the solution of how they work that out. Okay. It was 6 point. Okay. The first thing that they did is to make okay. What is going on here? 6 point. Okay. The first thing that they did is to make A be supposed to be positive. Yeah, that's what they did here. They changed A to be positive because original A was negative. So the reflection has to change A to be positive. And remember, on the original equation, we had plus 6, which is this one. This one is fine. This was a given equation. So we are saying we're going to insert negative here and divide by that negative. This will become positive, this become positive, and this become negative. That's what happened. Because this is now positive and this is positive, but this is negative. That's what happened on the first condition. Okay. The second condition, we said wherever we see x, we subtract minus 3. Minus 3. That's what they did here. And you then simplify that to end up having this equation. Okay, that's your answer. Remember, they were saying for which values of x would f of x be greater than 0? We said that each must be between -3 and 2. Alright, but we said that x has to be greater than -3, but it should be less than +2. If you are not clear with this part, you can raise your issue so that I can address that specifically when you understand this part. Okay. Let's go to 1.1 6.1. Okay, here they were simply asking us to determine x-intercept, which is pretty much straightforward, I think. So those are x-intercept being your B and your C. Okay. Then they ask you about axis of symmetry. So this is your axis of symmetry. I have demonstrated this part. Okay. And this was the range part. So you needed y value. Okay. So hence they determine the y value in the turning point. They also say turning point. This is the y value. But the graph has to be, the y has to be less than or equal to that value because the graph is curving downwards, it's moving downwards. Above this value, there's no, the graph doesn't exist, hence it starts at this value downwards. Okay, y has to be equal to this value and less than this value. Okay. Okay, this was where they asked us to determine the equation of g of x, and we had an advantage of the fact that we had coordinate of a and d. We determined the gradient. Thereafter, we used n of the coordinates to determine that equation. This is it. Okay. They also asked about the average gradient. You determine it yourself. You're still gonna get the same answer because I also said that this is simply the same as that one because you are still using the same coordinate. You are using exactly the same thing. Hence, the answer is still 1 for the gradient, right? I think this is clear. Yeah.